Greetings and welcome to trèSci Weekly episode 47. My name is Jonathan Ullman, alongside Mr. Tommy Pastrami, Tom Kea.
What's up, man?
What's going on? How are you?
Doing well.
Good. Kyle the Wiz Kalita over there running the stream for us, and Mush joining us passed out on the floor as per usual. And welcome to all of you guys. Thank you for joining us. You'll notice the setup is a little bit different this week.
A little more homey.
A little more relaxed. I feel like I got all this space, all this leg room, Tom. This is nice. How do you feel?
Feeling good.
Yeah?
Feeling like we should talk about some science tonight.
All right. We can definitely do that. Yes, if you're just joining us for the first time, welcome to the stream. This, of course, is our weekly video podcast show. I said I was going to get away from the podcast word, but I haven't been able to do it. Weekly show where Tom and I talk about all things trending in the science world, different research topics, different policy topics. We go through the Friday poll results and, just kind of whatever we want to point to our tip our hats to, I guess I should say.
Exactly. So we do the show live on YouTube. We have a live chat. We
invite you to chat with us, of course, if you're watching the live stream. If you're watching the replay, that's cool too. You can always watch this show for free on our YouTube channel. If you're on our YouTube channel, we would really appreciate it if you subscribe to us. That helps grow the stream, of course. Thumb the video up if you like it. Thumb it down if you don't. Let us know how we're doing in the comments, of course. And you can also follow us at various social media websites such as Facebook.com, Twitter, Instagram, and we have a Patreon as well if you felt obligated to financially support us.
And those are all trèSci Weekly.
Yeah, so
yeah.
Exactly. x.com/trèSci Weekly.
Where X is the various social media websites.
Exactly.
Okay.
It's a positive integer. It's imagine actually going to x.com/trèSci Weekly and then you get some real raunchy stuff. Yeah.
You want to stay away from X's.
Yeah. So Tom, tell me a little bit about your week before we jump in. Anything exciting happen?
Yeah, notable things from the last week. Well, we had that crazy day when it finally got warm for a little bit, and then all the snow evaporated, and we were in a cloud for a whole day.
Yeah.
That was pretty cool.
Yeah, the cloud world.
Yeah.
Kind of like Star Wars, the floating city.
True.
Yeah. Yeah, we had an electrician. We had 3 electricians come to our house this morning, so things were a little bit chaotic. You and I normally write the show together here. You were kind enough to invite me over so we could do it over at your place today.
But we're back.
We're here. That doesn't have anything to do with why we changed up the viewing.
No, we just wanted to do something different.
Yeah, we just wanted to lay down on the couch, really. All right. So, without any further ado,
let's get right into the story.
Yeah, let's jump into the lightning round.
Here we go.
Are you ready?
You want to start us off?
I can start us if you'd like. Numero uno.
All right.
We're talking about lots of accessible water ice on Mars, Tom. This story, I grabbed the Curiosity rover, Mars' Curiosity rover tweet for this one just because I thought it was funny.
You know what I was thinking? Does it tweet from the rover?
I think, yeah.
Does the rover tweet from the Imagine?
It's got its own AI and it's like...
It's tweeting while it does research?
Yeah.
Maybe the next one.
That would be awesome. They just actually send like a NASA intern up there just to do social media. That would be hilarious. Curiosity rover says, future astronauts, NASA identified 8 icy places on Mars where you can get all the water you need. Bring your own bucket and shovel. So
it's just right there underneath the surface?
Basically, yeah. We've known that there's been water ice on Mars for a while. You can see it during some seasons if you're looking through a telescope.
On the poles.
On the poles area. We've made some progress, and NASA has declared that there is even some flowing water, liquid water, on the surface of Mars, which is really exciting.
There has been in recent past.
There definitely has been evidence
That's positive,
in recent past, and they seem to think that there is actively in some regions as well. Now they're saying that they've identified 8 sites where there are these steep scarps, kind of like inclines or really steep hills. that I think are formed by impact craters.
Okay.
Where they've revealed that there are underground sheets of water ice, like lots of layered deposits of water ice.
And I was reading that some of them are up to 150 meters thick.
Yeah.
They're estimating.
So lots of it.
Lots of it.
Readily available.
So not that deep underneath this, the surface of all the red dust.
Exactly. And what's really kind of fascinating about this is that the locations on Mars where you might find these layered deposits of ice are not at the extreme poles. They're more kind of towards the mid-latitudes of the planet, which is nice because if we're going to send astronauts to Mars, well, we don't really want to go to the poles, right?
More extreme conditions right off the bat.
Yeah, not too many people live at the poles on Earth, so we don't really want to send people to the poles of Mars.
That's a great point.
Yeah, so this is interesting because it can also tell scientists a little bit more about the climate history, the recent climate history of Mars, similar to how we take core samples in glacial deposits here on Earth to try to get an estimate of like what the conditions were like. We can do now something similar on Mars if we were to send some sort of, lander or something over there to do it.
Exactly.
So, I wanted to ask you, Tom, do you think that now these new 8 sites, do you think that they automatically jump to the top of the list for prospective landing sites for future Mars rover missions, or no?
I guess they would have to, right?
I mean,
because we're always talking about... Excuse me. Oh, my goodness. We're always talking about liquid water when we want to discover things on Mars. Because liquid water is so essential to life here on Earth, that's what we're always looking for. So when you say we've got 100-meter deposit thick ice, relatively shallow on the crust of Mars, I think that's where you're going to want to go.
Yeah.
Right?
At least for future studies.
Not necessarily
the first humans to, eventually make their way to Mars.
We definitely want to study that.
Yeah, I would imagine so. It can tell us so much about what has gone on in the Martian climate that, we can maybe extrapolate and look to our own climate here on Earth and help kind of plan for the inevitable, future that humans have on Mars, I think. So, yeah, that's
pretty cool story, right?
Pretty good stuff, yeah.
Yeah. Good news for Elon Musk trying to send people to Mars.
Definitely.
Cool. Moving on from Mars, we're going from Mars to the sea turtles.
Oh, God, Tom, the sea turtles. Tell me about them.
This story, we're coming from sciencenews.org, and the basic rundown of this story is that more than 99% of new sea turtles that are born are female.
Wow.
99%.
That's
so we're talking it's actually even more than that. One male for every 116 females that are born. So obviously that's an imbalance.
Yeah.
And so we kind of want to know about why. So the imbalance has been going on over the past 20 years, and about 20 years ago, 86% of sea turtles that were born are female. So now it's just getting even more and more skewed towards the more female range. So why all the ladies is the question I think we want to know.
Yeah.
So the researchers are trying to narrow down what is causing them all to be female, and turns out it has a lot to do with how warm in the sand the egg is while it's getting ready to develop and hatch.
Okay.
So I think they're saying that the warmer beaches, due to the warming climate, that higher temperature actually triggers the development of the egg to be a female.
Okay.
Just based on the ambient temperatures that's around it as the egg gets hatched.
So
warmer beaches, more females is what we're talking about.
Gotcha. I mean, that's kind of true.
That's how it works. In every species.
Exactly.
But in this one in particular.
Yeah. Can you imagine if that were to happen to like humans somehow? Like not
extreme, but
like what if one day
for every one male there were 15 females as opposed to 100
like what if one day all the babies that were born or all one gender, right?
For one day.
Or like 99% male or like 99% female. What would we do? That would be insane.
And then we were having a conversation before about what are the sea turtles going to do about this. I mean, they're turtles, right? They're not like, oh man, we're all female, what's happening? You know, like, it is what it is kind of thing. And so I think the next logical step would be, it's sort of like a conservationist effort, right? It's up to us. We see the problem and we know sort of what's causing it. Yeah. So now I think the next step, it runs into conservation a little bit, because obviously if they're all females, you run out of turtles.
Yeah. I mean, this sort of thing, you have to imagine it's had to have maybe happened sometime to some species in the past, human history, right? Yeah. Do those species go through a population crash, or do they adjust, right? Would in this case the sea turtles figure out that they need to migrate to a place where the sand temperature is a little cooler to lay their eggs to balance out the ratio of male to females? How would they figure that out, right? Like, I don't know.
Yeah. I don't see how there could be a natural cue in nature to like signal to them to go another way. Yeah. If it's not that drastic of a condition to their environment where they live in.
Yeah. It's interesting because I don't know off the top of my head, but I imagine sea turtles have been around for a long time.
Yes.
So, like the Earth has gone through
quite a few changes.
Right. Lots of different temperature changes, and, a small varying degree of the sand temperature, like skewing all of the gender to one gender, just doesn't seem like
that's the whole story. But
I mean, maybe it is the whole story, but maybe this isn't a cause for concern. You know what I mean? I don't know.
Maybe it is more of a natural thing than a severe imbalance that we see it as. But either way, I think it's a conservationist issue that needs to be monitored going into the future.
Oh, for sure. I mean, it's interesting.
Because I like turtles.
I like turtles. Yeah,
I do. How can you not like turtles?
That's true. That's true.
How we doing in the chat? Anybody else like turtles a lot?
I think so, yeah.
I think everybody likes turtles.
Nancy says probably pollution. Pollution may play a role into this that we just don't see yet, but I think it's probably more likely associated to the temperature.
The climate, yeah. That's the only research-based news that I've seen about the issue.
Right.
Of something that could be causing it.
Yeah.
Kayla, I like turtles as well.
Of course she does. Moving on. Next up, we're talking a little bit about ice jams.
Ice jams?
Yeah.
Like ice, baby?
Yeah, it's like... Exactly. So we're looking at the National Weather Service in Burlington.
And every National Weather Service across the United States has their own Twitter handle. Even.
Yeah.
It's pretty amazing.
Yeah, it's awesome.
So you could follow your own local National Weather Service.
I was following, National Weather Service Key West a lot before the Hurricane Irma.
Yeah, so when you're traveling, that's a good one, too.
That was definitely good. But yeah, this is in Burlington, Vermont, I'm guessing. That's the only Burlington I can really think of besides...
Well, it says,
on
the river in New York.
Yeah, but New York and Vermont do...
They're right next to each other. Yeah. So it's somewhere up there.
It's somewhere north of here. Anyway, we're looking at an ice jam. This video is kind of a time-lapse video where you see really like not a whole heck of a lot happening as far as what's going on to the river until the very end, where we see lots of ice kind of accumulating down this river stream, and the water level itself just rises tremendously in a very short period of time.
So it's basically as if a whole bunch of beavers got together real quick and made a dam, but the ice did it artificially on its own.
It's a much less graphic comparison than what I was going to say.
Oh, you were going with something.
I was going to say, it's kind of like when you flush the toilet. And, we won't go there.
Yeah, so just an artificial dam doesn't let the water go through, so obviously the water rises, and you're going to get all that ice as it gets built up, and then it's all going to get pushed back as it goes downstream.
Right, yeah.
It's got to go somewhere eventually.
Exactly, yeah.
But the key thing is how quick they can happen, where we saw in the beginning that it just looks like a nice serene lake, but then as time goes on, you don't even see where the jam is. It's down the rivers a ways, and that's what causes the water to rise quick. And then out of nowhere, you get this almost flood-like conditions.
Yeah. Rivers,
so you need to know what's going on with your rivers.
Rivers are scary. Quick aside. When I was visiting my sister in Switzerland, she lives right on like a runoff river in the mountains. And every time I've gone to visit her, it's nice to go down there and like swim around or jump off the rocks and have a grand old time.
Sounds
it's
great,
yeah, it's good. There was like a storm the day that I arrived with her on this one particular visit, and I was like, oh, I really want to go down and check out the river, and she was like, yeah, I wouldn't do that. And I'm like, well, I mean, I just want to go down for a sec. And she's like, no, definitely don't. And I was like, all right, I guess I won't. And then overnight, sleeping over at her house that night, it was like a stampede out of nowhere. You heard the rush of the river just blasting down, what was kind of a calm and quiet, serene river just hours before.
Yeah. And I guess they know from experience. They've seen it.
Right.
And they're like, you got to be careful.
And it was still raging on, like rushing down the next morning. And I looked out and I was like, oh my goodness, right? Like I would have definitely got crushed. Swept up and killed if I just went down there. Because who knows when the moment is going to be.
Yeah, you can't tell.
Exactly. Yeah. So, pretty crazy stuff.
Also, just a really cool video. That's why I like to share it.
Yeah.
Real cool. Sounds good. Karen says she likes the new setup. Very casual.
Thanks. I like it too. I'm going to take a nap, I think, after the lightning round.
So we're moving on from ice jams to mudslides. So last week on trèSci episode 46, we talked about the mudslides that we were expecting. We were predicting them based on National Weather Service forecasts.
Yep.
That because of the large amount of area that got burned in the Thomas fire, the remains from the fire would act something like pavement and just block the rain from going into the ground and just cause massive runoff. And with less trees and not penetrating rainwater, you just get basically a river on the surface and it becomes a massive mudslide.
Yeah.
So we sort of painted the picture for this last week, and this story right now, we have a tweet from NASA, and you can actually see from their satellite view from space, you can actually see the mud as it goes into the Pacific Ocean, and you can see it get actually considerably more brown in large cross sections of the entire state of California.
Yeah. Yeah, we blew up these two images by clicking on them. I don't know if Kyle can do that for us on his end, but it's kind of tough to see on the land mass itself. But yeah, if you look just below the land into the Pacific Ocean, you can see it's relatively clear blue, or like a steady tone of blue in the ocean on the left panel, and then on the right-hand panel, it's murky, and you can clearly see that a lot of debris, a lot of mud has now flown into the Pacific Ocean.
Exactly. So
obviously, very unfortunate circumstances for the people
anybody living there.
Yeah, living there, and it baffles me that as many people were caught in this sort of mudslide as there were, because
so going over the numbers, I think they said over 20 confirmed dead, and there's still 4 people missing. And they're sort of redirecting their efforts from just looking for the people who are still lost for future prevention for the next time it rains.
Okay.
So that's sort of where we're going.
So this isn't a problem that's going away then, is what you're saying.
Exactly. So, exactly. We just had a whole bunch of mudslides. There's still the burn scars. It's not like the mudslides just made it better. They sort of just happened.
Right.
And they sort of redistributed a lot of the land that would fall, but this is going to be a reoccurring problem as rain happens again.
Mm-hmm.
And when you get a whole bunch of mud moving around, that's going to clog up your drainage.
Right.
So you get a whole bunch of murky mud sitting on top of your drain where all the water is going to go away. Obviously, can't drain.
Yeah.
You're going to get, as well as more mudslides, more flooding and things. So there needs to be actually large cleanup efforts we were reading about.
Right.
Where they're worried about if it happens again and we don't clear out all the drainage for it of the mud, we're going to get a repeat scenario.
Yeah. Now, they are expecting a little bit of rainfall in the forecast.
For
Montecito is kind of the area affected. There is an image, Kyle, if you don't mind bringing that up, from the National Weather Service. It doesn't look like a lot of rainfall. Montecito is highlighted here in red. It says rainfall estimate of 1/10 of an inch to 2/10 of an inch for Thursday night into Friday night. Not like something that you would really have to worry about.
Yeah, just a small amount of rain.
If the circumstances weren't, so dire right now for them, as far as, like you're saying, clogged drainage systems. Something to keep our eye on going forward.
Just another tough story for California.
Yeah, it's been rough over there for the later half of 2017 and now the beginning of 2018.
That's so unfortunate. One natural disaster causing another natural disaster. You usually don't see that, It's not like an earthquake triggers a hurricane. This is just one of those examples where the conditions just line up for the next one.
Yeah. But best of luck to everybody affected over there.
Yeah, just watch the forecast, and you gotta be ready.
Yeah. Watch more trèSci. Moving on. Next up, we've got another tweet by NASA here that we wanted to share.
Back NASA.
Yeah. This one is interesting because NASA has decided to launch a Twitch channel. Twitch being a streaming platform.
Oh, really?
Similar to what we're doing here on YouTube Live. Twitch basically has their own... Really, the platform is
the whole thing is live
streaming. For live streaming.
And it started off with video games.
Yeah, that's
actually
true.
Way back in the day, I think it was called Justin TV. Like the guy who made it, it was literally a website where a bunch of random dudes streamed video games.
Oh wow,
that nobody really knew about.
So now
it's this massive platform where
owned by Amazon, right?
They're partnered with Amazon now. Yeah. Okay. And I think or Amazon bought them or something.
I thought
because if you have Amazon Prime, you get Twitch Prime. Mm-hmm. So it's like a whole big thing.
Right.
What Twitch is really about is just like the live streaming, the live interaction with an audience.
Yeah.
So I think it's cool that NASA's going there.
Yeah.
It's a lot of young kids playing video games, a lot of just shenanigans, and I think it's cool that they're going over there.
Yeah, it's a great outreach opportunity, I think.
I go on Twitch, I would say, every day.
Really?
Yeah. I watch things.
I used to watch it a lot more. I haven't in recent times.
I just love to check it out.
Yeah.
I don't know. I'm a big fan of Twitch. And since we have Amazon Prime, you get no commercials on Twitch, which is awesome.
That is awesome.
So I don't get any ads. I just hang out.
So NASA's basically converted their NASA in Silicon Valley podcast to being a live Twitch stream.
That's pretty cool, right?
Yeah, it's nice they bring on people from the facility, interview them on what their work kind of entails and how they got into doing space research.
So it's like half podcast, half interview, half live show, 3 halves make a whole.
And I primarily wanted to throw this as a lightning story in there for us because this is something that we've talked about and plan to experiment with a little bit in the near future. So seeing NASA make the jump into Twitch
going over there
is
inspiring.
Yeah, is inspiring and sort of helping me make my mind up on what kind of things we should test out and try out in terms of like launching trèSci into a place where we might grow it with a larger audience. So obviously more details to come in the future, guys. Nothing to
write home about.
Yeah, nothing to worry about. We're not abandoning you, after the show. But I think we are going to take a look at what Twitch can offer as something, like us, as far as what we want to do with streaming.
Yeah, because we're a live show. We might want to head down there and make YouTube videos at the same time. We'll see.
Yeah. Very cool.
Yeah, but I'll be down to check out some NASA streams. I want to see what they're all about. I want to see the vibe. I wonder what chat's going to be talking about.
Yeah.
I definitely want to check it out and see how NASA does on Twitch.
Yeah.
I'll be interested because I love Twitch to death. It's one of my favorite things in the world. But being a member of a lot of different communities, there's a lot of interesting people on Twitch.
Yeah, there's a lot of
like you meet so many people play games and like to hang out on that platform. It's a cool place to be, honestly.
Bob Ross is on Twitch too. He's a cool guy.
That's true. Yeah, they ran the Bob Ross marathons for a while.
Yeah, that was one of my favorite things they did.
That was funny.
Take a look at the chat. Moroccan Night Fang joins us. What's up, Mike? Good to see you. Thanks for coming in and hanging out with us. Other than that, I think we can keep going.
Sounds good.
Nancy Cleta said she likes turtles too.
Ooh.
That's where Cosmos is from, I think.
So the next story, after NASA goes to Twitch, we're talking about the show Cosmos.
Oh!
So we're talking about the reboot that was done on Fox just recently with Neil deGrasse Tyson as a narrator. I think it starts off with him in like a spaceship-looking thing, and the background is like he's in space, and he's like, "Welcome to Cosmos," or something like that. And it's like it's just all about science and space. And I ended up watching every episode, and I was a big fan of the show.
Yeah,
they do a really good job of taking science, relating the story of the society and culture that came up with the scientific ideas at the time, and then telling you the scientific facts of the stories. So I don't think I've ever gotten a better, well-rounded, artistic picture of some scientific stories than I did get on Cosmos. So I would recommend it. It's a good show.
Yeah, absolutely.
But it's not until 2019.
That's true.
So we gotta wait a little bit.
Hey,
so plenty of time to watch the first season if you missed it.
Right.
You know?
And take your time with it, you know? Like,
yeah, you don't want to binge watch it. This isn't Stranger Things.
Yeah.
Okay, guys?
And as far as them making it, like, take your time making it.
Oh, yeah, make it good.
Make it awesome. And I know that they will. Neil deGrasse Tyson is phenomenal as a science communicator and an astrophysicist, to boot. I was really pleasantly surprised when Cosmos, the reboot, was announced, back a few years back to air on Fox, following Carl Sagan's original Cosmos series that came out in the 80s. I was like, wow, that's so cool. I'm surprised that they would do this, and that that Fox would be the ones to air it. I thought that was uncharacteristic but interesting. I'm not as surprised that they're doing a sequel here, Tom, or a new season, because I think that the high production documentary is really it's ready to stick around. It's growing. I feel like that movement of telling these really fascinating stories with cinematic oomph behind them is really catching on for the general public. We see that with Planet Earth returning for Planet Earth Season 2 last year. We see Blue Planet 2 is about to premiere here in the United States this upcoming weekend, actually.
Oh, yeah.
I'm really excited about that. Cosmos, what is it? Cosmos Possible Worlds is a no-brainer. Of course, it's going to, why wouldn't they do it?
So my only point I want to make about that is that Planet Earth and Blue Planet and those kinds of things, I think those were made possible because of our amazing advances in like HD photography and things like that. So I think people always sort of liked them, but now with the quality of production you can get with those kinds of shows, like people are really like, gimme, that's good stuff.
Yeah.
So I don't see in Cosmos that they go overboard with trying to like use crazy graphics or anything, but in the same sense that it is a documentary style show where they do a lot of production and a lot of work into creating a beautiful story of science in the same sort of way that they do on those other ones.
Yeah,
I agree. I think it's a great way to get ideas out about all kinds of different topics.
Couple questions for you then, Tom, because
Sure.
you just sparked my noggin with that last comment. Do you think that Cosmos, maybe not necessarily this particular season that's going to air in 2019, but do you think that they'll follow up with a third iteration of Cosmos that then shows some of the advancements made by the new telescope projects that are underway.
I could see that, yeah. Moving into the James Webb.
Yeah, James Webb Space Telescope, Large Synoptic Survey Telescope. These are major scale projects, that are going to be coming online in the next few years. And much like, the high-speed slow-mo cameras that allowed planet Earth to kind
sort of revolutionize how we see,
I could see them going that route and being like, now here's the next new benchmark.
Yeah.
Look at what we can see in space now. This is
who knows what we'll see, right?
And then my next question is so we've got Planet Earth. This is like a wildlife biology documentary series. And then there's spin-offs, Frozen Planet, Blue Planet, yada, yada, yada.
Yep.
Cosmos, obviously, astronomy-based. What discipline of science do you think could do something of this?
Like a Cosmos?
Right, of this, large-scale documentary type. What would you like to see?
Yeah. That's a tough question, because astronomy is so just a beautiful thing to look at, as well as the nature documentaries, that focus mainly on biology. But you could come up with all kinds of cool stuff with geology and looking at things like that.
Yeah, geology would be awesome, man. To show
have you ever seen that show on? I don't know what channel it's on, but it's basically how it's made, but for the Earth. That show. They're how did this feature get made? And then they go through it.
No,
I think it might have been on Nat Geo, but
okay.
It's something that I would like to see get taken to the next level.
Yeah,
because it's kind of standard. It might be HD, but it's it's your run of the mill pictures and stuff. So it'd be cool to see that taken to the next level.
Yeah, and
really get into some cool geological formations and stuff.
Yeah, that would be awesome.
Some more maybe slow lava flows. I know a few people who do that.
I know a certain tweet by a certain somebody who's been on trèSci before is getting a lot of attention for his lava flows.
But yeah, geology would be a cool one to get into.
Yeah. What about you guys in the chat? What do you want to see aside from Planet Earth and Cosmos? What do you think?
What are you trying to watch?
Caracalita says the LSST is moving forward. He says BBL. I think he means BNL. It just delivered the first part of their contribution. I saw that. That the rendering of what the LSST facility is supposed to look like in Chile. It was a sleek design with rounded, rounded building. Yeah,
fancy.
And I've seen some pictures now of the building in progress, and it looks just like it. I'm like, wow, I am so impressed. They're really killing it over there. So
awesome. And that's in Chile, you said?
Yeah. So on top of the mountain range over there. The Andes Mountains.
The Andes Mountains?
Yeah. Somewhere in the Atacama Desert, I think.
Yeah, Atacama,
yeah. Very cool, very cool.
Cool. Thanks for the update.
And last but not least, on the lightning round, we have a tweet from Science Magazine saying, what can and can't quantum computers do better than standard ones? A $40 million Department of Energy project could bring us closer to an answer. So, basically, the DOE is now moving forward with an investment to build quantum computers, Tom.
The Department of Energy.
Department of Energy. This is interesting for a couple reasons. A, quantum computing seems to be kind of the next hardware pursuit, I think, right?
Yeah.
The other thing that I was comparing it to is the driverless cars, where you see lots of tech companies and automobile industries, all saying, all right, this is going to be the future. We're going to do this. Quantum computing seems to be in a similar fashion, where
IBM, Google, Microsoft, they're all investing quite a bit of their funds.
Their R&D, right?
Yeah.
Their research and development teams into developing these things.
So it only makes sense that the federal government should be doing some of their own research.
Absolutely.
So we don't have to just rely on tech giants for quantum computing.
Yeah, you guys should read the article because it's a fascinating one. But they mentioned here that the $40 million investment is not necessarily to build a quantum computing
System
computer,
itself.
right? That they want to commercially like sell, or that they want to really like push the cutting edge of quantum computing with. They really just want to build something that can help with the current research
Science.
that they're already doing at the Department of Energy. And some of those topics include chemistry, material science, nuclear physics, and particle physics. And some of the things that they want to investigate with quantum computing, Tom, is looking at how interactions between molecules, between particles, really happen at that molecular level, right?
Yeah.
You have to use something that is basically as versatile and small as a single
The thing you're studying.
right
Yeah.
subatomic particle, because we're already there, right? We're already working with things that small to develop, new
Technologies
medicines,
right now, yeah.
right, new materials. They have the particle collider over at Brookhaven National Lab, which is DOE run. So this, to me, makes a lot of sense.
Yeah,
right?
definitely. And kind of like how you mentioned that they're not really trying to come up with their own sort of quantum computing system, but it follows along their mission statements, where they're going to be using this technology to further things they're already doing.
Right.
With doing the research in chemistry, material science, nuclear physics.
It's basically
It's just the next step in computing power.
Yeah.
And they're recognizing that it's going to be utilized in a lot of scientific research endeavors.
Yeah, I would say it's a way to not have to rely on the major industries. Are we looking at Mush? Yeah. The major tech companies. If they're going to be the only ones in the race here, then what is the Department of Energy going to do? They're going to contract out Google to basically run the future experiments forevermore? Like, no,
They have to have some sort of
Right.
infrastructure and funding.
It's similar to how NASA has to keep up with what SpaceX is doing.
Yeah,
because
they can't just fall behind.
Yeah.
Exactly.
There you go. All right.
So, just to close out quantum computing, because every time we say it, I like to sort of talk a little bit about sort of what it is.
Okay.
I know
Please
it's
do,
tough.
I don't really understand it fully still. But yeah, go for it.
Yeah. So why are the big tech companies realize that it's the future? They realize the power of it, and what they're really seeing in it is, I think, the possibility of sort of replacing what supercomputers do now, but on a smaller scale. So when we talk about scientific research all the time, we mention the models, the simulations, and what are we learning from all this computing, basically.
Yeah.
And all the tech companies are realizing that, the way the computers work now, we keep, more and more transistors, more and more computing power. We add them all up, and then we get to use the supercomputer. So the promise of quantum computing, to me, is really the ability, let's go take a step back. When the first computer was made, it was the size of a room. And now, when we look at our smartphone, how powerful it is, to me, the way when I read articles, they say quantum computing is going to be a similar fashion where we have supercomputers now that are literally the floors of a building, that being able to utilize the way quantum computing works, where you don't need the ones and the zeros, you don't need to just get all of them built up. You have a system that can account for more possibilities, and is in itself just a more complicated and intricate system based upon real life phenomenon.
Yeah.
The quantum state of the atoms themselves. It's sort of just, the new hardware, the new circuitry is the very subatomic particles themselves making up a super powerful computer that doesn't have to be the size of a room, that's built on thousands of transistors and millions of transistors. It's just sort of the next step in understanding the very small world that we are jumping into with nanotechnology and stuff, and taking those properties and putting them into a more realistic, feasible scale of computing, and move on to the next level of computing power in a reasonable size.
Right.
That's sort of like the general, without getting too technical into what's really happening.
Yeah. And yeah, I mean, at first these are going to be primarily used to replace supercomputers, so they're not...
eventually, like the same way the computers got fed into society, you'll see it eventually, right?
Yeah, I would imagine so. I don't know that we're all going to have a need for a quantum computer.
I don't see why we would. I think they would be extremely expensive all the way throughout their existence. I don't see them getting cheaper like 4K TVs, like it seems to be a very complicated process.
So we'll see what happens.
We'll keep following.
But that race is certainly heating up, and I would expect major news out of quantum computing ventures
in the years to come.
Within this year and the next couple of years. Tom, that's all we got for the lightning round.
So we ran another poll this week.
We did. We've got the results for this week's Friday poll. The poll boiled down, see what I did there, to boiling point versus freezing point. And the winner this week was freezing point. Took the vote 18-10 in the victory. So
nice.
I thought that, it would be interesting to do sort of like a like a chemistry, physics, phases of matter sort of a head-to-head combat here. Because I've been doing, I did like a dinosaurs one, I did like a nebula one, so I wanted to see all right, if I use kind of a more dry science topic, will people still vote and respond? And I was delightfully pleased that people still participated and gave me some pretty funny answers. I was reading to you the one. My one friend said that Boiling Point sounds like a Liam Neeson movie, but that said he still voted for Freezing Point. I like how you guys give me your logic behind
why you pick.
Why you pick what you do. Kayla was telling me that she took a personal stance on whether or not she was going to be killed by being frozen or killed by being boiled. And she said probably freezing would be an easier way to go. So there you have it. Your winner this week is Freezing Point. I don't know if Kyle put up the picture there of the ice cubes that Chris got the nice ice tray that we use, and all of our frozen ice pops underneath in the freezer.
Yeah. It's really amazing that it all comes down to a single point of energy, basically. It's like when the phase change, where you remember the diagrams in chemistry, or for anybody who doesn't remember, that you can't really get any energy in or out of the system. All of it gets put into transferring it from a solid to a liquid or a liquid to a gas. When you get to that exact point, it's no longer energy you can give it. It all goes into the phase change.
Yeah.
It all comes down to that little tiny point of an equilibrium, and it goes one way or the other.
Yeah. And what I think is somewhat fascinating too is when we think about the liquid phase and how seemingly rare it is in terms of matter in the universe, right? There's lots of gaseous clouds and
gas everywhere,
gas nebulas all over, well, not all over, but we find them
throughout the universe,
throughout the galaxy and throughout the universe. We know that there are planets out there. There are, solid bodies out there, and even stars are, stars that have kind of gone through their entire life cycle turn to solids, right? They are solid.
At the end of it, they're just a rocky body.
But nowhere aside from the Earth, possibly very, very minuscule trace amounts on Mars, and on Titan, Saturn's moon, do we find liquid. The liquid phase.
In the liquid phase, yeah.
At least on the surface. There is our liquid mantle within the Earth, but we don't know that there are too many liquid phases
that's a
within
That's a good point to make, that it is just on the surface, basically, here. And so when we look for it throughout the universe, like you said, it's going to be in different conditions. It's so nice that here on the surface of Earth, we just get so many varying conditions where we can have liquid water because of our atmosphere, because of various different things that allow it to be that way. But when we're looking for it in other areas, like we're talking about on Mars, it's it's just completely different.
Yeah.
All the conditions are different.
Yeah. Well,
So-
like you said, it's the special sauce, right?
Yeah.
It's really important to life as we know it, and that's why we look for it. It's
Yeah.
because we need it. So,
Exactly.
Yeah, very cool. Moving on.
So that was the poll.
That was the poll. This week, Tom, we regularly...
We had a few write-ins.
Yeah, we regularly ask you guys to tag us in things on social media sites that, you think would be relevant for us to talk about on the show. And this week, we got two...
Which is awesome.
2 tags, yeah. So thank you to you guys that did that. The first one came by way of our good friend Gerard. He tagged us in a Facebook post by the page Woodworking Tips, because Gerard... he's a
he cuts
woodworker.
down trees. He's
I
an
would tree
arborist.
service if you ever are in need. I'll read the post, and Kyle, you can bring it up for me if you'd like. It says, "For all our dog hunters out there, in 1980, a logger found the dog after processing the log and donated it to a museum. The dog is a hunting type dog and around 4 years old. Apparently was in there for around 20 years. Scientists believe his fate was sealed when he chased something up into the tree. The plinth next to Stucky in
That's
the
the dog's
museum..."
name?
Yeah,
Okay.
Stucky is the dog's name. More on that in just a second. In the museum gives an explanation on how the mummification happened. Quote, "A chimney effect occurred in the hollow tree, resulting in an upward draft of air. This caused the scent of the dead animal to be carried away, which otherwise would have attracted insects and other organisms that feed on dead animals. The hollow tree also provided relatively dry conditions, and the tannic acid of the oak helped harden the animal's skin." End quote.
So that's in the museum?
Yeah. So Gerard asks, "Is this
Is it
real?"
legit?
Yeah. trèSci should find out.
Oh, I get it. Stucky. I get it.
Yeah. So trèSci did some investigation here.
We tried to see.
Yeah. So I plugged in that quote into Google. Just did a Google search, just to get some more information.
See what it's all about.
I don't want to diss woodworking tips because I don't
sure
know.
they're great. Yeah.
I don't know how valid some of their information is, but I wanted to get some more sources here, and I found that yes, Stucky is the name of the dog. It was voted on or submitted. Yeah, that was like a contest.
Okay.
And the museum that it was donated to is Southern Forest World in Waycross, Georgia.
Okay.
So it exists, right? It's
a real exhibit in a
It's a real
museum.
exhibit in a real museum.
It's not just a meme.
Right.
But okay.
It's not
But
totally...
is the science legit? Do
Right.
you believe in it?
Right. Do you believe in it? Do you believe? So I wanted to try to figure this out. And so the dog appears to be what we would say mummified.
Almost mummified.
Yeah. And so their mummification is, a process that particularly we associate with the ancient Egyptians, where they would remove, body parts and drain fluids and embalming and all that stuff. But there is a natural process that can happen. It's called spontaneous mummification. And what has to occur in order to become spontaneously mummified is you sort of have to be in either a really dry, condition upon death or a really cold condition upon death.
Okay.
And you have to basically lose more water out of your body faster than the lysosome release of digestive enzymes.
That break your own system down.
Exactly. So, yeah, you have digestive enzymes in your cells. Your lysosomes hold them back from digesting your body as we speak.
Because death is a pretty natural process.
Of course,
you just get re-put into the earth. Mm-hmm. So, like you said, you just need those really dry or really cold conditions to stop that from happening.
Yeah. So, can this happen to Stucky the dog? Would it be possible? So
Karen, I like what you said in the chat. Petrified, not mummified. So, I kind of see where you're going with that one. It's kind of also like, like when you get a deer head put in your house. What are those things called? Taxidermy?
Taxidermy, yeah.
It's another way of just preserving. So like mummification way is preserving, taxidermy's way of preserving. These were just a certain amount of natural conditions in this tree that allowed the dog to sort of naturally be preserved from the cold temperature, the way the tree was made, and the dryness and coldness.
Yeah.
just all together.
Yeah. Now, I may be incorrect about this, but petrification, I thought, is more associated with when organic material becomes a more mineral-based.
Yeah, so once that the technical definition of a petrified exactly is when you have a mineral transfer causing some sort of crystallization effect of part of your organic material becoming mineralized or crystallized.
Right.
So I don't think this was technically becoming petrified.
Yeah.
I think it was more along the lines of the slight mummification and how do they say it here? I forget, but yeah, more of like a mummification and like the drying out of the skin, the tanning.
Yeah. So let's go back to what the exhibit says about it. They say that a chimney effect occurred in the hollow tree, resulting in an upward draft of air. So I'll ask Kyle to bring up the first image here. This is possible because of something called the stack effect. The stack effect is basically an extension of Bernoulli's principle that when you have, kind of a tall
column of air.
Column with two openings, one at the bottom, one at the top, depending on the temperature of the surrounding air, you will get airflow from either the bottom to the top or from the top to the bottom. And so taking a look at this image, which comes to us by way of cppwin.com, we can assume that if this chimney effect did take place, that the dog must have gotten stuck in the tree during the winter time because of how there must have been an upward draft of air then.
Carrying the scent away.
Right. So it must have been cold relative on the outside. Cold air then comes in through the bottom of the tree trunk, up through the hollow inside, and then out as temperature rises, up through the top. The next sentence I am still a little iffy on, where they say, this caused the scent of the dead animal to be carried away, which otherwise would have attracted insects and other organisms that feed on dead animals. I don't particularly buy it, right? Like, there are insects, in Georgia. There just are. It doesn't.
All the time.
Yeah, it's not even like Long Island where it gets cold and a lot of the insects, die. Like, this year has been pretty cold for Georgia, but for the most part, it's pretty temperate year round. And then even if the scent was carried away from the top side, there are scavengers that, there are birds that are scavengers that I would
pick away at.
Right. I would figure they might catch that scent, but I'm willing to give the benefit of the doubt because of the last piece of evidence here. They say that the hollow tree also provided relatively dry conditions, and the tannic acid of the oak helped harden the animal's skin. According to the USDA Forest Service, I wanted to read up a little bit about tannic acid. They say, quote, tannins are complex chemical substances derived from phenolic acids, sometimes called tannic acid. They are classified as phenolic compounds, which are found in many species of plants from all climates and all parts of the globe. They are large molecules that bind readily with proteins, cellulose, starches, and minerals. These resulting substances are insoluble and resistant to decomposition.
So the tannins were sort of a natural way to preserve it.
Yep. And
it came right from the tree.
And the word tannin actually comes from an old German word, tanna, meaning oak, and they say that it was an oak tree.
Okay.
It refers to the use of wood tannins derived from oak trees that were used to convert animal hides into leather. And Stuckey had sort of a leathery complexion to him. So I'm going to give this one...
It's legit.
It's plausible, right? I don't know that it's fully legit, but it's plausible.
That's one of those weird stories where so many conditions had to happen for it to happen, where you'd probably never see that again if it did happen legit.
Yeah, exactly.
I don't think you'll ever find another petrified dog inside a hollowed out tree.
Probably not.
Not for a while.
No.
And then, thanks for Gerard for bringing that one in. That was cool.
Thank you for that. And then the second one, we want to thank our friend Angela, who tagged us in a Science Nature page video on Facebook as well, that depicts the Japanese research drilling ship, the Chikyu.
The
Pikachu. I won't show the video because obviously we don't want to get slapped with copyright infringement on that. But yeah, Angela basically also wanted to know if this was a real thing that was going on.
So they were drilling all the way to the mantle.
That was
the page was saying.
That was the claim, right? Is this ship is going to drill 7 kilometers down, basically
through the ocean floor,
right? Through the ocean floor, and be the first ship to reach the mantle of the Earth. Tom,
so, what is the mantle?
Yeah, you tell me.
Yeah, so there happens to be, that's the biggest chunk of the Earth is the mantle. So you have the core all the way in the middle, and then you got the little crust on the outside, and everything outside the outer liquid core, in between the outer liquid core and the crust, that's the biggest part of our planet is the mantle. And in the mantle, you have, it's basically a solid form of rock, but it has some sort of plasticity to it where it can flow, but not flow on a time scale that people really could relate to.
I see.
So it basically goes nowhere in 100 years, but in 100 million years, you get a lot of flow and movement throughout the mantle. So it's a cool, kind of crazy place of weird physics and interesting geology. So I think it's amazing that we're trying to go and, reach the mantle.
Yeah.
It's the major part of our planet. It has a lot of cool stuff.
Yeah, we've never
really got to check it out.
Sampled, right, directly. So this is a project that is part of the Integrated Ocean Drilling Project, something that the Japanese are heavily kind of involved with as part of JAMSTEC, which I don't know why, but I didn't write what those letters stand for. We do have an image to bring up here as well, showing what this particular vessel, the Chikyu, has already accomplished.
Okay.
So let me bring that up for us as well. Here we go. And a lot of the research has been done off the coast of Japan, not too surprisingly, because one of the main goals of funding this project was to help understand what causes major earthquakes versus what causes kind of minor earthquakes. And Japan obviously very affected by the repercussions of that with tsunamis that can be generated, which we saw.
They're right on a volcanic island arc themselves, so they're prone to earthquakes there. As we saw with what was that in
2011, I think?
I can't remember, but the big earthquake that affected the nuclear reactor.
Yeah. Fukushima. So, don't get your hopes up because, I guess, get your hopes up, but temper your expectations because the Chikyu is not really expected to undertake this drilling operation to the mantle until sometime in the 2030s at the earliest. Yeah, so right now they're still surveying 3 different sites in the Pacific Ocean.
Where they want to try it?
Right. One off the coast of Costa Rica, one off the coast of Mexico, and the last one off the coast of Hawaii.
And each of the locations would be through the ocean floor.
Right.
Because if you just started at the crust, you got to dig through the entire thickness of what the ocean would be. So you want to start drilling at the bottom of the ocean floor.
Right.
To make your hole you're drilling actually not as crazy deep as you would think it would have to be.
Yeah. It's an interesting question. How deep of a hole
do you have to dig?
Right. Do you have to dig? And have we achieved? So if this is a successful mission and
we actually
research topic,
gets carried out,
this will become the deepest or absolute depth of a hole that has been man-made. But that's not to say it's the longest hole in terms of depth.
So absolute depth down into the crust, but not the actual length of the longest.
Because like you're saying, if they're going to start from the bottom of the ocean, that's different than starting at sea level on land or somewhere in higher terrain. So the actual record holder right now for absolute depth is the Soviet undertook a project back in 1989 called the Kola Super Deep Borehole. So that right now is the record holder for absolute depth. And that's something like 12 kilometers, whereas this one would be 7. But right now, the longest kind of measured depth is the Al Shaheen oil well in Qatar, which has a measured depth of 12.3 kilometers. That's pretty far.
Pretty deep.
That's you don't want to fall into that hole. That much I can tell you.
Yeah.
So thank you to Angela for tagging us in that one, because that's a cool project that hopefully we're still doing trèSci by the time it happens
in the 2030s.
Yeah.
And we'll follow up.
Exactly. Tom, we're pretty much out of time. We're going to leave you guys with a quote by Dr. Martin Luther King Jr., because it is Martin Luther King Jr. Day.
Exactly.
And this was something that he said in terms of discussing education.
He's got a lot of good quotes.
A lot of very good quotes.
He was a legend.
He was. So, Tom, I don't know. Do you want to read it off, or do you want me to?
I'll read off the beginning part.
Sure.
So, quote coming from Dr. Martin Luther King Jr., "As I engage in the so-called bull sessions around and about the school, I too often find that most college men have a misconception of the purpose of education. Most of the brethren think that education should equip them with the proper instruments of exploitation so they can forever trample over the masses. Still others think that education should furnish them with noble ends rather than means to an end."
Deep stuff.
It is.
What do you take from that?
I really do like that. It reminds me, I remember hearing Neil deGrasse Tyson talk about science and how it should be used, where as you understand something new, there's something noble about explaining it and making your research open and available to the public, and not using the knowledge that you've gained to take advantage of other people who don't have access to that knowledge that you have. Using the knowledge as a base to create, a slate that we can all look at and appreciate the knowledge and research that everybody does together, as opposed to using what you learn to just exploit other people for your own means. It's a good way to look at education.
Yeah, I very much agree with that. Dr. King would go on to say in that same passage, quote, "To think incisively and to think for oneself is very difficult. We are prone to let our mental life become invaded by legions of half-truths, prejudices, and propaganda. At this point, I often wonder whether or not education is fulfilling its purpose. A great majority of the so-called educated people do not think logically and scientifically. Even the press, the classroom, the platform, and the pulpit in many instances do not give us objective and unbiased truths. To save man from the morass of propaganda, in my opinion, is one of the chief aims of education. Education must enable one to sift and weigh evidence, to discern the true from the false, the real from the unreal, and the facts from the fiction." End quote.
It's a good quote.
Yeah, and I think it's very relevant in today's society of, fake news and distrust of the media
and learning to fear and hate things.
Yeah, exactly. And I couldn't agree more with that. We need, as a people, to do our research and to dig a little.
Yeah, cite your sources.
Well,
I'm just joking.
We have to dig a little deeper than surface level, I think, and that's kind of what we try to do with trèSci. That's kind of what this whole venture is about. Is not really just taking things at surface value and redigesting them out for people to consume, but really trying to think more about what is being done in terms of actual research and trying to sift through, some of the less true stories that are out
trivial.
There. Right.
Good stuff, though.
Good stuff. So, Tom, thank you so much for joining me on this episode of trèSci Weekly. I hope you'll be back next week.
For next week. I hope you guys are all back next week. And don't forget to tag us. It was really cool to read up about the petrified dog as well as the mantle drilling.
Yeah, definitely. Thank you guys all for joining us this week. And we'll be back next week, same time, same place. So
and I hope you enjoyed the couch.
Yeah, I'm going to take a nap now. See you later.
Bye, everybody.